All right, so today our topic is Grazeable Acres, and so this slide kind of illustrates the point of this webinar. Not all acres are grazeable, and this particular picture here, right here, this is on the outside of a pasture, a ranch that's just one pasture, about 2,000 acres. And the stocking rate is 64 acres per cow based on the total acres on the ranch. And the livestock specialist and I worked on this ranch for a couple of years on a project, and we estimated that there was probably about 85% dense brush cover on the ranch. So taking that 85% dense brush out of the acreage, that gives us an effective stocking rate excuse me, of about 9 acres per cow. So that's a pretty high stocking rate. And so one of the things that the livestock specialist and I discussed at the time was how could we show people this concept of grazeable acres. And so we just kind of stumbled on the existence of these GPS collars. I guess it was probably maybe 15 years ago or so that we started working with these collars. And the first work that we did was on the Freeman Ranch, which is over near San Marcos. It's run by Texas State University. At the time it was Southwest Texas State. And so we partnered with the Freeman Ranch and Southwest, and did some work there. This is the Freeman Ranch, and it's basically consists when we look at range sites or soil types. It basically has about 99% of the ranch was in what we call rumple comfort, or comfort rock, and those translate into some ecological site names that we'll be discussing here as we go through. So we started on this ranch, and this is one of the trials that we ran. The green dots here show where the cattle were located, and then those blue rings show a half a mile from water, and all the water points are indicated here by these blue dots that you see here, and then the red line, that's a mile from water. And so what we saw in this trial was on the gravelly redland site, which corresponds to the rumple comfort soil. There was a 2.5 to 1. The cattle favored that gravelly redland site by 2.5 to 1 GPS points per acre over low stony hill. And so the question kind of is why is that the case? Now you can see that circle I just drew there with the yellow circle. That was a concentration of GPS points in one of those gravelly redlands areas. And we're going to show you what that looks like in this next slide. So that's kind of what that area looks like. It's got some scattered live oak trees, mott's, and then it's got open area in there. So it's an area that the cattle really favored. So again, the question is, why do they like it? And then down here in pasture 10, there's not one GPS point in that pasture, and all the pastures open up into this water right there at that blue dot. And so the question is, why did they not go in that pasture? If you look over here on the right where I'm showing the arrow, there's a cluster of GPS points. So the cattle are kind of congregating at that fence line there, and it looks like if they could get in that pasture 10 they would. So why don't they go in pasture 10? So this is what the entrance to pasture 10 from the water looks like. We've got a electric fence here that separates the pastures, and we've got this area here, a sendero that they can walk down and get into the pasture. So it looks like there shouldn't be any problem with them getting in there. But when you start to look at that entrance, you start seeing this rock like this, and even boulder type rocks on the surface of the ground. And then it's just another shot of the, it shows some of the boulder type rocks. And then over to the right of the entrance to the pasture, there's this dense brush. And so it appears that there's two barriers to the cattle going into that pasture. They're keeping them out of their rock cover and the density of the brush that it's hard to get through. So what we did to look at rock cover was we ran transects or lines in the pastures that we grazed, and in these gravelly redland sites and the Rumpel Comfort, and looked at GPS points or rock cover on a percentage basis. In other words, we had a frame we laid down and we estimated how much rock there was in there. So we got out to 30% rock cover. That's where cattle tended to not want to go into those pastures. So just kind of keep that 30% figure in your mind, because we're going to kind of refer to that again here in a little bit. So the gravelly redland site, it can contain up to about 30% rock cover, which is above that, just above that 30% threshold that we think we saw there on that ranch. And then the low stony hill can have up to 50% rock cover. So that suggests a reason for them having a preference for the gravelly redland over the low stony hill. In other words, less rock here in the gravelly redland than in the low stony hill, and so they kind of prefer those areas. So this is another ranch. This is 4 years later. It's a different set of cows. It's even a different breed of cows. And these blue dots here show where the cattle were in this one pasture here. And again, what we're seeing is for a preference ratio of 2.5 to 1 for the gravelly redland over low stony hill. And what you'll notice as well is that there's this area right here I just outlined with that yellow polygon. There's no GPS points in that area. So again, the question is why? So we went to this yellow dot here, and we did a lot of ground truthing on these photographs to find out what was going on in those areas. And so this is what that area looks like, kind of a dense wall of brush. And so we actually developed a brush density scoring system of 0 to 5, and I'll show you what that looks like here in the next slide. But what we saw there was when we ran these transects, and so when we had a score of 1, there was 80% use in those areas. When we had a score of 2, 73, and then a score of 3, it dropped down to 25, and then when it was up to score of 4, there were no GPS points in those areas. So this slide here, the next one, yeah, there. This shows our scoring system, and up here where we got 0, there's no brush in the foreground, so there's no barrier relative to brush. And then over here, the one that we give a score of 1, you can see some scattered brush in here, but there's no reason that animals can't get around that brush and graze. And then here in 2, we start to see a little bit denser, but they can still get around in here relatively easy. We get to a 3, they can get around, but they've kind of got to meander through these openings here that we see. And then we get to 4, a score of 4. There's still some little openings, but they're hard to find. And then the 5, that's a solid wall of brush, and it's even hard to crawl in some of those areas. So that's the scoring system that we set up to look at the brush density. And on that scoring system, that those pictures are in this publication right here. Is called Estimating Grazeable Acres for Cattle, and this is available on our bookstore, and the address is agrilifebookstore.org. The unfortunate thing is that you have to set up an account. You can download this publication for free. It's a PDF file, but you do have to set up an account with a username and a password. But as I said, once you got that set up, then you can download this publication and any PDF file in there that's a free publication to your computer, and print it or keep it on your computer, whatever you want to do. So that scoring system is in that publication, as well as some text that talks about what we saw. So this is a graph that shows 3 South Texas areas that we looked at relative to brush density score. And so here is South Texas 1. We had on the grazed areas in green, we had a score of just a little over 1, and in the ungrazed areas we had a score of less than 2. And what this p less than 0.1 means is there's no statistical difference between these two. In other words, they used there was no preference for the grazed area or ungrazed area based on brush. But if we go here to South Texas 2, then we see that we've got a brush density score of 2 on the grazed areas, and then when we get to the ungrazed, that jumps up to a 4, and then we've got that p-value there that's highly significant. The more zeros you've got, the more significant it is. And we saw the same kind of thing on South Texas 3, a score of 2 for the grazed areas, and a score of nearly close to 5 on the ungrazed. So very similar to what we saw on that Edwards Plateau Ranch. So the brush density scoring system looks like it works. Good indication of what's going to happen in terms of cattle use. So this is this next few slides is just a project. It's kind of interesting that we did this back when GPS started to be used. We had a field day on a ranch down in South that A&M owns in South Texas, and what they did is they GPSed a pattern in the pasture, and then they took this Lawson aerator and they chopped the brush down inside that pattern, and then later on we turned the cattle into that pasture, and so these dots show where the cattle were within that pasture. And I just take a second or two here and see if you think you can see a pattern that you recognize in that pasture. And if somebody recognizes it, how about if you text it? I mean, type it in the chat box. We'll see if anybody sees the pattern. I see Pete's typing, but he's disqualified. Okay, all right, okay. Cole, RJ Cole sees the shape of Texas, and RJ, you're exactly right. That's what happened. The cattle outlined the shape of Texas, which was the pattern that was chopped down. And then we'll look at it a little closer here. What we saw was inside the Texas map, there were 4 times as many GPS points in this gray sandy loam site and also in the sandy loam site inside the Texas pattern as there were outside in the same pasture. So what happened was suppressing that brush with that aerator, and then actually with a subsequent fire, helped suppress the brush enough that it improved the grazing within that area. It also concentrated the cattle in that area, so that area could get hammered pretty well. And then you'll see some holes here where they're not grazing, and so there's some brush in those areas. And I'm going to show you this right down on the coast here. We've got that circle. We're going to look at that on the ground and see what that looks like, so you can get an idea of why they didn't go in that area in particular. So if we look at that area, what we see is there's a plant, this subshrub. It's in South Texas they call it Tedalentia. It's also up in the hill country they call it sticky saloa. And so it's a subshrub that the cattle don't eat, and it's thick enough in here that there's not enough grass in there for them to make it worthwhile for them to go in there and try to graze. They've got enough area that they don't have to do that. So that's why they're not going in that particular area. All right, so back to this other hill country ranch that we worked on 4 years after the Freeman, and we look over here at that yellow circle, and there's no internal fences in this pasture. So this circle here, there's no GPS points in there, and so the question is, well, why not? And if we look kind of close, just from the aerial photograph, it looks like there's not a lot of brush in there. So we're gonna look at it from the ground, and this is what it looks like from the ground. So what I'd like to do is we got a little quiz question here, a little survey question, and so we'd like you to tell us what brush density score do you think the foreground, or in other words, the area in front of that tree line has a 1, a 2, 3, 4. So we're talking about this area that's in front of the tree line out here in the open, but in front of the tree line up to the bottom of the picture. Okay, so we got some people voting. Tell us if you think it's a 1, 2, 3, 4, and then we'll discuss it. Okay, looks like we got about 12, so about half of you have voted. So we'll go ahead and we'll talk about it here. I would give it a score of 1 or 2. I'd agree with either one of those scores. There's not enough brush really to qualify this area for any higher score than that, because the cattle can get around, around here. You get to the tree line, and yeah, it's going to be thick back there, but up here, away from the tree line, it's pretty open, even with these little shrubs, these little juniper shrubs there. So I'd give it a 1 or a 2, and most of you agree with that. All right, so why don't they go in there? Well, this is what the ground looks like in that area. And what we've got is we've got these kind of volcanic type rocks laying all over the place. And so on that particular ranch, what we saw was when the brush density score was less than 28% rock cover. I'm sorry, the rock cover score, not the brush density score. The rock cover score was less than 28%. We had 68% of those areas used. But when the score was greater than 28% rock cover, only 12% use and 88% non-use. So if you think back to the Freeman with where we had a 30% rock cover threshold, that threshold is pretty well holding because there's not a lot of difference between 28 and 30. So kind of a good rule of thumb is if you're dealing with mature cattle, if it's uncomfortable for you to walk on, it's going to be uncomfortable for them to walk on, and they'll probably avoid those areas. I'm not saying that you can't get them to go into those areas or they won't go into those areas ever, but they're going to avoid them if they can. So that's the reason that they stayed out of that area. And one of the, in where I've done face-to-face presentations with this information, one of the guesses I get sometimes is the grass, that it's KR blue stem. Well, then that's a good guess, but on this particular ranch, the dominant grass was KR. So no matter where you went, that's the major grass that you ran into. Okay, so here's I think we lost something in here. Let me go ahead. Nope. All right. Yeah, this actually what we did is we used these frames to estimate rock cover, and actually what we did later on is we built frames that had that were divided into quarters, 4 quarters, to make it easier to estimate. So this particular first slide here, we're looking at, we estimated that was about 10%. So what we're trying to do is we're looking at 1 quarter, how much of that quarter of that frame is covered, and we estimated 10%. And then over here, the next one is 30. So that is, we think, a little bit more than 1 quarter, so we gave it a 30% score. And one of the things that you might be wary of with the rock cover, it's rock cover more like what we see down here in the 50s, those loose rocks like that, rather than a flat rock that we've got up here. And then when we get to 50%, that's going to cover 2 quarters of the frame, and then this one over here, 70, that covers almost 3 quarters of the frame. So again, I think when we transferred this slide over to Pete, we lost something because I had drawn lines in here artificially to kind of show you the quarters. But we actually did later on build frames that were divided into quarters to make it easier to look at that. So again, that particular photograph is in this publication that you can get from the bookstore, from the agrilifebookstore.org. Yeah, and Pete put the Pete put the web link there. Okay, so I'll just stop here a second and see if there's any questions, and if there's not, then we'll kind of go through the next group of slides. Okay. I don't see anybody typing, so we'll go ahead. All right. So one of the things that we looked at was how water access might affect grazing distribution, and I really got interested in this concept when I was in graduate school, and they use it in New Mexico, and they call it best pasture. And so what they do is they have a lot of convectional rainfall events out there in New Mexico, and so if you have a 10,000 acre pasture, you might get rainfall in a quarter of it, and the rest of it would not get rainfall. And so what they do is they would push the cattle to those areas that got the rainfall. And the other thing that they do is they would control access to water in those areas. So what we have here is this is a pasture on the Freeman Ranch. It's about 240 acres, and it's got water at the north and water at the south. And so in this part of the trial, what we did is we had the collars turned on for 2 days, because we can program the collars to come on and off according to a program. So we had collars on for 2 days, and this is what looked like. And so again, we see that 2.5 to 1 gravelly redland to low stony hill preference ratio. So we turned the water off at the south, and then turned the water on up here at the north, and our ratio jumps up to almost 4 to 1 preference for this gravelly redland site up here at the top. So we turned the collars off for 2 days to let them adjust, and then we turned the water at the bottom on, and we pull the cattle down to that area at the bottom, and we get back to about a 2 to 1 ratio. So the kind of take-home message from this is we've got this desired site up here at the top. If we only give them access to water up there, they're gonna hang around there. If we want them to come down here to the area, the low stony hill that they don't really prefer, we're going to have to draw them in there. And one of the ways we can draw them in there is with water. And you'll notice that we never overcame that preference for the gravelly redland, but we did get better distribution when we only gave them access to that south water. So as you can see, there's still green dots up there. It's still grazing up there. Okay, so this is another trial that we did looking at water access, and this is out in the Davis Mountains. This is a 4,000 acre pasture, and there's no internal fences. So the way they control grazing distribution is with these water troughs. They've got water troughs in here, 1, 2, 3, 4 locations really. These two at the bottom are awfully close to each other, so they're really not they're gonna cancel each other out. So 4 different locations. And so what they do is, if the cattle were down here in the lower right-hand corner around that water point, if they want them to leave, they turn the water off, let them drink it down, and turn it on up here at the north if they want them to move up there. And so during the trial that we ran, these 2 water points at the north were on, and the ones at the south were off, and you can see that they do congregate up there at the north. And so, you know, the question is, these cattle around that water point on the right, they're moving from, you know, kind of east to west, and the ones here on the left, they're moving kind of north to south. So the question is kind of, why are they doing that, and why aren't they moving more in a southerly direction? So we're going to take the points off, and what we see is over here on the right hand side, if you look closely, there are ridges that are running east and west, and over here on the west side of that water point, we don't have those ridges, so we don't have that kind of barrier to keep them from going north to south. But over here on the right, these ridges are keeping them from moving very far south. And we'll look back at, so that's what we think that's why they only came about a half a mile from water instead of all the way down here a mile from water, which water access on smooth terrain, you know, they'll go a mile from water. But when you get into these rough areas like this, maybe just a half a mile, but they are moving over a mile east and west. And again, I think that's due to those ridges that we see on that part of the pasture. Okay, so we know that gullies and rocks, which create rough terrain, are going to affect grazable acres. And so what we're going to look at slope. What does slope do to grazable acres? So we got another quiz question for you here. And this picture is right across the road from that 4,000 acre pasture. So the question is, above what % slope do cattle generally avoid use? In other words, if it's above 10%, is that when they quit those areas, or does it go up to 30% or 45%? Okay. Okay, we got about 60%, or well, 50-some % of you are saying 30, about 30% are saying 10, and then about 14% of you are saying 45. Okay. You got about 14 votes. All right. So let's take a look and see what really happens here. All right. So this is cumulative GPS points. We were able to identify the slope that the cattle were on within that pasture. And so what we saw was that by the time we got to 11% slope, we were accounting for about 95% of the GPS points. We do have some cattle over here at 29% slope, but 95% of the points are accounted for by the time we get to that 11% slope. So if you go to a range management textbook and look up effective slope on grazing for cattle, it will tell you that about 10% is where we start to see cattle avoid those areas. Again, it doesn't say that they won't go up here to 29%, but most of them, I mean, this is we've got 95% of the points that are at 11% or below. When we get to, if we're talking about goats, then goats even up to 45%, they're okay. But for cattle, that 10% slope is going to potentially affect them. One of the ways to get around those things is if the cattle have trails where they can kind of zigzag to up the slope. But for them to climb directly up the slope, it's difficult for them. Okay, so this is another ranch that we worked on in the Edwards Plateau, and on this ranch there were 3 different pastures. Here's 1, 2, 3, and we spent 7 days in each pasture, rotated around from one pasture to another, and the green dots will show you where the cattle were. In terms of ecological sites or range sites, there was a steep rocky site, a low stony hill site, and then we had a redland site, and we had a gravelly redland site down here, and a deep redland site right here. So you see a lot of concentration right in this area right here, where we got the redland, this low stony hill, and the redland here, and over here in the gravelly redland. Right here we got a steep rocky that surrounds this low stony hill, and another steep rocky surrounding this low stony hill, and again over here, steep rocky surrounding that low stony hill. And this particular low stony hill here has a lot of brush on it, and right here we got a lot of brush. So what you notice is that this low stony hill here, and here, we have no GPS points. And the one that I'm pointing to right here was especially interesting because the landowner had cleared that top. I was working with the lessee, so I don't really know why the landowner cleared it, but they did clear that low stony hill's top of brush because we had an earlier aerial photograph that showed brush on it. So you can see that there's no GPS points in this steep rocky site or in that low stony hill. So, why would that be? Well, surface rock on the steep rocky is anywhere from 35 to 65%. So we're above the threshold at the bottom of that range. And in terms of slope, 15 to 45% is a typical range for steep rocky site. And some sites will have anywhere from 20 to 60% slope. So again, we're above that 10% slope threshold that cattle typically avoid. So this is a 3D view of that area, and this circle here, that's where that steep rocky site is. And you can see that there's really not enough brush density to keep the cattle out, but there's when we ground truth this, there's quite a bit of slope here, and there's also a good bit of rock. And I'm going to back up here a couple of slides. Yeah. Okay. This low stony hill that I'm showing right there with the arrow. When we did ground truthing, we actually saw cattle up there. And the reason we did was there's a Jeep trail that they can get up on that one, on that area with. So if you've got trails that create access to those kind of areas, you can get use in those areas. But over in this one and this one, we didn't have that access, and so they stayed out of those areas. Okay, so another thing that affects grazeable acres is forage preferences. And in this particular photograph, you can see this grass is not being grazed, and those that's a situation that we refer to as patch grazing. And there are several reasons that you might see that develop. If you've got differences in palatability between forages, that could develop. If animals, if cattle defecate in these areas, they'll avoid those areas and allow these patches to grow up. More often than not, it's difference in palatability of species, though. So in terms of what grazing animals like, not just cattle but grazing animals, they prefer live over dead tissue. They prefer leaf over stem. And in Australia, some studies that they did there showed that as much as 80% of the diet can come from 1% of the forage. So they can, what that says is these grazing animals can be very selective. So this is typically what we see cattle diets in South Texas look like over the year. In the spring, and in all of these seasons, the dominant forage is going to be grass. So here in the spring, we've got 85% grass. We've got about 2% browse. The rest is forbs, which are weedy type plants, herbaceous weeds. Summer, we have more forbs, but we have still the browse is only about 3%, and we see that through the fall. Again, browse is only about 2%, and over here in the winter, that's when we see the most browse in the diet. So grass is the major forage for cattle, followed by the forbs. So in our studies on a ranch down in South Texas, what we did is we established some transects or lines in areas that were grazed that we could tell have been grazed by the GPS points, and then we selected adjacent areas to those that grazed area that didn't have any GPS points in them, and we went through and identified the grasses and the frequency of the grasses on those transects. And so what we saw in the grazed areas, we had 6 different grasses that made up more than 30% of the composition of grasses on that transect. But on the ungrazed areas, we only had 1 grass that made up more than 30%, and that was a 3-on species. And so what they're doing is they're avoiding that 3-on and going to these other grasses. So that's just an indication of their selectivity for certain species. And the 3-on, if you're not familiar with it, it comes out early in the spring. Typically, it doesn't have a lot of leaf material. It'll be useful for maybe a few weeks, and then it gets pretty stemmy, and the animals avoid it. And then it also has seed heads that have 3-ons. That's where it gets its kind of generic name from. Okay, so this is another pasture down there on a South Texas ranch that we looked at, and we had a predominance of Clayburgh bluestem, which is kind of similar to KR bluestem. Not a very palatable grass. Has a lot of stem versus leaf, more stem than leaf. And so in the grazed areas, we had about 45% or so Clayburgh bluestem. In the ungrazed areas, we had about 65% Clayburgh. So what that suggests is that there's a tendency for them to avoid those Clayburgh bluestem areas for other areas that have other grasses in them. Okay, and so that's the last slide, and what that means is that I'm done talking, and so we're going to see if you have any questions. We'll be glad to answer any questions that we can. Say what?
Yes, if you have any questions, type them.
Okay, Cole's RJ's typing something here. Okay, what is the preferred grass for most cattle? That's a good question, but it's kind of relative. In general, let's just say generic grasses. The more leaf a grass has, the more likely it is to be preferred. But within a pasture, you start out with a grass, say a grass that's really highly preferred, and if they graze that out, then they'll switch to some, a grass that's on down the pecking order. So a grass in the hill country that's, for example, that's really highly preferred is yellow Indian grass. It has a lot of leaf material compared to the amount of stem it has. Little blue stem is a preferred grass. Big blue stem is. So, like I said, in general, the more leaf it has, the more likely it is to be preferred. Now, one exception I can think of there is when we get into some of the Muhlenbergias, the muleys, like Seep muley, for example. It's got a lot of leaf material, but it's also a really tough leaf. And so leaves that are a lot of leaf, but leaf that's palatable. So as I said, it depends on what the grasses are in the pasture, which one is going to be the preferred one.
Yeah, I'll go ahead and have any questions. Y'all feel free to type them in the chat pod. In the meantime, while you're doing that, I'm going to pop up a survey. All responses are anonymous. Please answer them. And One other thing is our next session is going to be on January 3rd, 2019. Prickly pear management, and Mr. James Jackson is going to be our speaker. And we actually have one IPM CU attached to that one. If you're not following us on Facebook, you can follow us on Facebook, facebook.com/txrange. We try to post twice a week with some kind of educational posting.
Pete, one thing I might mention is that some of these things we talked about, like for example, steep rocky site. There's nothing we can really do about that. But if we're aware of that, then that can influence our stocking rate. In other words, we're not going to stock based on the total acres. We're going to stock according to grazeable acres. So water is a good tool where we can try to change those grazeable acres or improve those grazeable acres. But sometimes there's not. It's more being aware so that we stock properly.
There's a question that come in. I don't know if you can see it. It says, how about side oats grama grass?
Side oats is a good grass. It would be a preferred grass. It's a native, cool, native warm season grass that is a very good forage. Yeah, and just happens to be the state grass of Texas.
I popped up the survey. If it covered up your screen, you can actually click on the little green icon. It brings you back to the Adobe Connect. And if you didn't get it, there's a link on the screen that you can click and open up the survey. Okay, Doc, I don't see any more questions coming in. I'm gonna go ahead and
Okay.
stop the recording here.